graphs of y is equal to negative f of x and y is equal to f of negative x. So I looked at the square root function because it's sometimes the easiest one to see this transformation, and we know the graph of the square root function is this. Well, I've looked at what negative f of x is, right? Negative f of x, that is an outside change. In other words, it is affecting the y values. Okay. Because remember, on our square root function we have the 0.11, the 0.42. Well, on negative square root of x, notice what happens. The graph flips over the x-axis. Because now we have the 0.1, negative 1, and 4, negative 2. See, the y values are changed, the x values stayed the same. So the graph, I'll say real mathematical terms here, it flipped over the x-axis. There is actually a precise mathematical term for that, and I'll show you that in just a minute. What happens if we change the x values? That is, we take the opposite of the x. So here we have an inside change, and we would expect an effect on the x values. And notice the effect of the domain and range, and I'll talk about that too. The square root of negative x, so remember that f of negative x means to replace x with negative x, which is exactly what I did here, and look at the graph of this. It did what? It flipped the graph, so we're comparing it to the original function here. So what's going here, but now when we did it, the square root of negative x, it's going here. So it actually flipped the graph over the y-axis. What is domain and range? Let's just talk about that. Original function domain from left to right is 0 to infinity. The range is bottom up, which is also 0 to infinity. Because remember that point 0, 0 is my bottommost and my leftmost point. For the negative square root of x, the domain is still 0 to infinity because the leftmost point is at 0, 0 and it's continuing to the right. Now the range is affected here, and we would expect that because the y values were changed. Now it's going from negative infinity up to 0. For this transformed graph, my domain was affected, which is what I would expect since the x value was changed. It's from negative infinity to 0. Now the range was not affected because we didn't change the y. It's from 0 to infinity. Okay? So let's make a conclusion here about the true name that we can call this. The graph of y is equal to f of negative x is a reflection of the graph of f across the y-axis. So when we're inside changing the x values, we're reflecting across the y-axis, because if you think about this, okay, if my x values are positive here, right, when I flip them over the y, they become negative. And that's what we're doing, right? We're taking the opposite of x. Well, the opposite of x are on the opposite side of the y-axis. So that term reflection is a real mathematical term for flipping over the x. It's kind of like a mirror image, right? If you see your mirror image, you're seeing the opposite of what you would think. The graph of y is equal to negative f of x is a reflection of the graph of f across the x-axis. Why is that? Because if we're changing the y values, here the y values are positive, but they have to be flipped over the x to become negative. So we're flipping it over to take the reflection. And I'm looking at a few examples just again so you can get a picture of that. And I've started with this function, y is equal to the quantity x minus 2 squared. So that's one of the shiftings of the parabola, but it doesn't really even matter. I'm just trying to start with one function and then taking the negative x inside and then the negative on the outside. So this is just a picture of my original function, if you will. So let's look at what happens if we take the opposite of that. So this is really the same thing as y is equal to the opposite of f of x. So if we're thinking about this as being my function f of x, y is equal to negative f of x. So this is changing the y values, right? Taking the opposite of the y. And you can see that in the table. My x values were not changed, but my y values were all opposites there. And in doing that, that's going to flip the graph over the x-axis. So this is a reflection across the x-axis. Alright, you can see that. If you even had a picture, or a piece of paper rather, and you had this graph drawn on the paper, and you folded that graph on the x-axis, or even you flipped it over vertically, you're going to get a reflection of that graph. Now let's look at what happens if we replace x with negative x. So this one is really y is equal to f of negative x. Notice what happened. Now the graph went from on the right side of the y-axis to the left side. It flipped over the y-axis. So this is a reflection across the y-axis. So it's interesting to note what happens here. Like if this 3, 1 is on the graph of the original function, notice what's here. It's negative 3, 1. So my x values were opposite, but my y values stayed the same. I can do that over here too. If 3, 1 was here, what was on this graph? It was 3, negative 1. So in this first case, the x stayed the same, the y was opposite. In the other case, the x was the opposite and y stayed the same. Now, we've talked a whole lot, really a lot about different types of changes that you can have. The different transformations, we can have a vertical shift, a horizontal shift. A vertical shift was denoted whenever you had f of x plus a number, I'll call it k. Horizontal shift was whenever you had k added to the inside of the function. A vertical stretch was when we had y is equal to a times f of x, where a was greater than 1. Now horizontal stretch was when we had y is equal to f of a times x, okay, where a is greater than 1. Nope, I said that wrong, didn't I? Stretch is when a is less than 1. A vertical shrink is whenever you multiply by a factor of a, where that value of a is less than 1. A horizontal shrink is when you multiply the x times a, where a is greater than 1. A reflection across the x. Now think about that. If you're going across the x, what's changing? The y values are changing. So this is where you have negative f of x. I have to think about that every time, so it's okay for you to kind of visualize that. A reflection across the y. Well, across the y is where the x values change, and so that's going to be y is equal to f of negative x. Okay. Now the key is going to be able to put all of these together. And whenever you have to identify changes and go from one basic function to a transformed graph, the really key thing that you need to know is that you need to perform the x-axis changes first. Anything pertaining to the x-axis has to be done first, and then you can do all the y-axis changes. So what things pertain to the x-axis? A horizontal shift does, right? Or a horizontal stretch or horizontal shrink. And then a reflection across the x-axis. So you would need to do those first, and then you could do all of the other y-axis changes. So let's look at an example. We have f of x is equal to negative x cubed plus 1. What would we need to do here? Well, first thing you need to do is identify what changes are being described. First of all, notice that your basic function is y is equal to x cubed. So we have an inside change where we're having a negative x on the inside and a plus 1. Well, what did the negative x? So we're looking at the effect of f of negative x, and we're also looking at the effect of f of x plus 1. Okay. Well, what happens when you change the inside by negative. You're taking the opposite of x. That was reflection across the, do you remember which axis? Yeah, so if x is changing, that's reflection across the y-axis, right? And then we're also adding something to the function, which is again another transformation in the y direction. This one is not a reflection, but it is a vertical shift up 1 unit. Now, since both of these are affecting the y, you don't have to really worry about the order. You could actually do the order in either way. So what you need to do, you can certainly enter that onto the calculator, but you need to be able to have the ability to describe that in words, what's happening. But let's think about that. What is the basic function? X cubed is one of those that I'm hoping you know. It has a point 0, 0, 1, 1, 2, 8, and then -1, -1, and -2, -8. So what happens if we reflect that across the y-axis? If we reflect it across the y, notice what's happening. I wrote the y, didn't I? Let me make sure I'm reading this right. So yeah, we're taking the opposite of x, but the y value is staying the same. Okay. So whenever we do that, -2, -8 would become what? 2, -8. -1, -1 would become 1, -1. So what am I doing? Make sure you follow me. I'm taking the opposite of the x. So the opposite of -2 is 2, but my y value stays the same. The opposite of -1 is 1, and the y value stays the same. 0, 0 is unchanged through that. 1, 1 would become -1, 1, because the opposite of 1 is -1. And then we would have -2, 8. Now understand, this is only the first part of the change. Okay? This one is just a reflection across the y. Then I have to shift everything up 1 unit. So to shift everything up 1 unit, now I'm going to add 1 to the y values. So instead of -2, 8, I would be at -2, 9. Now again, if you had graph paper, that would be awesome. -1, 1 would be at -1, 2. 0, 0 would now be at 0, 1. 1, -1 would be at 1, 0. And 2, -8 would be at 2, -7. So here I just had to add 1 to the y values. To go from this direction, I had to take the opposite of x. And then my graph still has the same shape. It's just picked up and moved. And if I had graph paper, that would be really nice. Okay. Now you could do that on the calculator, and you can see here this is the final result, and these are the points that would be on the graph. I've done the transformation in stages just so you can kind of see that. This was my reflection across the x-axis and then the shifting of the 1 unit. Okay, so if you have any questions, please don't hesitate to contact me. Thank you.